Good afternoon, ladies and gentlemen. My name is Bharatwaj Kumaresh, call me Bharat, working as an executive surveyor here in SLA, and I'm going to play the role of MC and moderator for this event. On behalf of DU and SLA, I would like to welcome you all for this DUConnect session. Thanks for taking out time and joining this DUConnect event. Before going into the actual session, let me give you a brief introduction about Digital Underground and the DUConnect community of practice. The Digital Underground project is a collaboration between Singapore Land Authority and Singapore ETH Center that aims to establish a reliable digital twin of all subsurface utilities in Singapore. Through research and collaboration, following an integrated approach, the project aims to identify, develop, test, and recommend the workflows, supporting instruments, technology, and capabilities for the establishment of a sustainable utility mapping ecosystem. The project is supported by the City of Zurich, between the poles, Singapore Institute of Surveyors and Valuers, ESRI, Bentley Systems, and Leica Systems. Digital Underground consists of multiple phases. Upon conclusion of the first phase, a roadmap was delivered that details an integrated approach and strategy to achieve the desired goal. In second phase, the foundations of the ecosystem were further developed and described, resulting in detailed recommendation of subsurface utility data governance and infrastructure for data management and consolidation, techniques for surveying and mapping, and capability development. Our current phase, that is the Digital Underground Phase 3, focuses on building workflows for reliable data quality. This phase started in 2021 and is expected to run until the end of 2023. It aims to put previously developed recommendations into practice, evaluate and further refine them as workflows in pilot studies, together with utility companies, surveyors, and other key stakeholders. Furthermore, it will continue to build a thriving community of practice, public-private sector engagement, address challenges for the reconciliation of legacy data quality and visualization of subsurface utility data quality through new research. In October 2019, the DUConnect community of practice was established. This is the agenda for today's session. I will take you through this in detail later. Now that you have a fair understanding about Digital Underground project, let's all understand more about our participants. Let us do this by using Mentimeter, a real-time voting platform. All you need to do is log in into menti.com and type the code below. I think. Give me a second. Yeah. So type the code below or scan the QR code with your phone and log in into it with your name. The login information is also available at top of the slide. Yeah, my colleague has pasted the link for today's session. You can click that link. I can see people joining. We have got around 150 participants. So let's wait for some more time for everyone to join. Again, I can repeat, you can go to the menti.com and enter this code 86725270, or you can scan this QR code. I can see more and more people joining. Okay, so we have got 3 questions in this first session. These 3 questions are just to make you familiarize yourself with Mentimeter and to know your thoughts. Feel free to choose the answer of your choice. There is nothing right or wrong. Ready? How many? Okay. So the first question is, let's know where you're from. Which part of the world you're from? Time to brush your geography skills. Good, good. You can see people from Southeast Asia, ASEAN, or Europe, Australia. Good. I think it's New Zealand. Someone around Pacific, Atlantic. There's a bunch of people from, I think it's from Singapore. Someone from Arctic. Good, good. Nice, nice. Okay, good to have diverse participants. Okay, so now let's go to the second question. Yeah. How do you interact with subsurface utility data? I am a data producer. I am involved in regulation and coordination. I use them for my work. I develop or promote solutions for data capture. Please select the one which you are closely related to. Again, we have got a wide spread of people from all the 4 disciplines. Good. Hope you'll get a 360 view of all the technologies and challenges. Thank you. Thank you. Thanks a lot. Now let's go to the third question, which is, what is your degree of interest and familiarity with 3D reality capture technology and 3D data? I'm familiar and I'm already using them in my daily work. I am familiar but not a frequent user of the technology or the data. I'm interested but not sure whether to adopt the technology or how to utilize it. I'm relatively new and still exploring. And we have got people from all the different categories. Good, good. Thank you. Thanks for the time, and thanks for the polls, and request not to close this window as we will be revisiting this page later. With this brief introduction to DU and DUConnect, I would now like to welcome the host of this event, our beloved Director of Survey and Geomatics, Singapore Land Authority, Dr. Victor Khoo, for a word of welcome and more about DUConnect. Over to you, Dr. Victor Khoo.
Thank you, Bharat. Just want to confirm you can hear me.
Yeah, Victor Khoo, we can hear you.
Thank you. Thank you for breaking the ice and also for the introduction. Good afternoon, everyone, online as well as on site in SLA. First, I have to apologize that I'm not able to be there in person today. So it is my pleasure to welcome you to this 8th edition of the Digital Underground Connect event. This event is also known as a DUConnect in short. We are happy that DUConnect is growing stronger every edition and able to attract strong interest from local community, as well as followed by many friends from overseas. So DUConnect is back after a quiet period. Today it is in hybrid mode, which is the best of both worlds. So we have people in the office, in Revenue House, as well as we have many participants online. Let me share the background of DUConnect with you, a short one. Recognizing that it is a complex ecosystem in the underground mapping workflow, SLA and Singapore ETA Center initiated DUConnect as a community of practice that aims to contribute to reliable underground information. So DUConnect was launched in October 2019 in partnership with Bentley and Singapore Institute of Surveyors and Valuer, or SISV. On this platform, we wish to bring together professionals and stakeholders to discuss, to share, to meet, and to improve. Bharat, can you change to the next slide? So over the past 3 years, 2019 to 2020, we had 7 sessions with more than 12 speakers featured, conducted at various locations, both in person and online. So this year, in May 2022, for the first time, DUConnect collaborated with DUConnect Asia 2022 to conduct an expert stage as a component of the conference. So the collaboration was a success, and we already plan to work on the next year's DUConnect Asia, which will be held in March 2023. Between now and next March, do watch this space. We will have at least one DUConnect in between. So for today, we are having 3 speakers of diverse background, from research, from private sector, a pipe laying company, and a water supply asset owner. So they will share with us their experiences on adopting 3D reality capture technology, specifically for subsurface utility. So we hope this will provide a diverse view of capability and reliability of the 3D reality capture technology. So I will let Bharat give you the detailed introduction to the speakers, and I wish you a fruitful seminar. Thank you. Bharat, I'll leave the floor back to you.
Thank you very much, Dr. Victor Khoo. We have got 3 wonderful speakers joining us, 2 sitting with us here in SLA, Dr. Lasse, postdoc researcher at IT34 and visiting researcher at the SESC, and Mr. Shane Shi, director of HSC Pipeline Engineering, and 3rd speaker joining us remotely, Ms. Michaela, project manager for water supply assets, Kalundborg Utility Company, Denmark. Before inviting our first speaker, I would like to show you the agenda of today's session. We have 3 talks of 20 minutes each, followed by a Q&A session for 10 minutes after every talk, and audience poll for few questions. We also have a small toilet break in the middle of the session. Physical participants may feel free to raise their hands and ask the questions. Our team will help you with mic, and virtual attendees may type the questions in Q&A pane. And Rob, who has volunteered to be an online moderator, will pick them up and can read them out loud for you. Tea and snacks will be served at the back. There is also a pantry at the side. Please help yourself, and restrooms are behind you. I request everyone to wear the mask throughout the event, except during eating, drinking, and presenting, and sanitize your hands regularly. Fire exits are also present behind you, and in case of fire alarm, please do not panic. For further instructions, our fire marshals will guide us. We have kept copies of Digital Underground book on the table over there, and consciously kept very few hard copies in playing our part in minimizing the carbon footprint. But you can scan the QR code to download the ebook version of the same. For online participants, the QR code is displayed on the screen. Feel free to scan the QR code and download your copy of the book. My team can also share the link to you in the chat pane in case if you face any difficulties in scanning the QR code. The file is a bit huge, around 7.5 MB, so it might take a couple of minutes to download, but please wait. Yeah, thank you. Now I'd like to introduce our first speaker, Dr. Lasse, who is going to speak about SmartSurvey, an introduction to low-cost barrier to entry data capture solutions. Dr. Lasse is an industrial postdoctoral research at Danish Geospatial IT company, IT34, and Department of Planning at Aalborg University, Denmark. His research centers around digital transformation in the underground infrastructure domain to improve how subsurface utilities are captured, maintained, and visualized in order to help planners, contractors, and asset owners in their daily task. In particular, the application of reality capture and augmented reality technology are the topics of his interest. Currently, he is a visiting researcher at the Digital Underground project in Singapore. Welcome, Dr. Lasse.
Thank you. Thank you, Bharat, for this nice introduction. Oh, I can hear myself. It's a bit of echo, but it's okay. Yeah, maybe we should turn. Okay, much better now. Perfect. Yeah, welcome everybody. So I'm honored to do the first presentation here, and I will be talking you through SmartSurvey, which is a solution, a product my company has developed. And let's get right into it. So first, I want to address this 3D reality capture. What is it really like? It's a bit buzz-ready, right? We chose it for this session. And yeah, it is kind of a buzzword. You can say it's like capture reality in 3D. That's one way, and there's many ways to do it. So for instance, here, this is one of our mobile mapping solutions from Denmark, where we get a 3D representation of the environment. And actually, on this category of 3D reality capture, there's a lot of different technologies and outcomes of this. So it could be from drone imagery, photogrammetry, laser scanning, or even also like a lot of mobile phones now have LiDARs to scan. But what we will be focusing on today, at least the solution we used for our 3D capture solution, is clone range photogrammetry. So photogrammetry, just a brief introduction, is think of it like a picture is the science of taking something 3D and project it into a 2D image. Photogrammetry is the opposite, right? So take some 2D images and recreate it in a 3D scene. So that is what we have used for our technology. And now let me introduce this low barrier to entry data capture. So I choose this word because I see both our solution, SmartSurvey, and other solutions in the market it can be categorized as this low barrier to entry. And it's really because of the power of the new technology, all the powerful sensors that we have in our smartphones that we carry out each day. So this was really our idea, was to take your everyday phone and try to turn it into you can say a 3D scanner, but something that take a video and create it into a point cloud. And the objective is really to try to make a point cloud or take a point cloud that has high relative and absolute accuracy. So this is what I will try to show you today, like how we can do this with the SmartSurvey. So I and together with HSC, these couple of days we have been hitting the streets and testing out SmartSurveys and other 3D capture solutions. So this is me with Dexter, Kian, and Fuji, and this has really been great that they made this opportunity. And actually, what I realized doing this, that Singapore is very, very hot. I had the original idea that we should do this out on the street, so we should just gather around and try out these capture technologies. But oh my God, it was thankful that somebody told me, okay, let's just video record everything and take it back into here, so we don't have to struggle for the heat, because it is really hot out there in Singapore. So this is what we did. This is from Middle Road, me and I and Dexter, and I will take you through the data capture workflow. So the first thing you need to do is to spray GCP markings, so ground control points. And you can do that with your a spray paint or something like that. And our recommendation is to do at least 4 markings close to the circumference of the excavation. And the other thing we also have been implemented in our data capture workflow is the use of a scale bar. And this scale bar, you also place that close to the excavation hole. And what it has this visual markers, and these markers is exactly placed 50 centimeters in between each other. So our photogrammetry algorithm detects these visual markers, and then it knows that these are 50 centimeters in between. So the next thing you have to do is, of course, to video record. So we made SmartSurvey very versatile. You can take whatever phone you have, Android, iPhone, and then you have to do like a smooth and steady movement. Recommended is having a bit of tilt. Also, really capture the pipe of what is interesting, and also remember to capture the GCP markings and the scale bar. So actually, if we just stop here and only have these 2 data, only have the video from the iPhone, because we have the initial GPS from the iPhone, nothing really, accurate, but we can get an indication where we are. We can make a 3D point cloud just out of that, and yeah, I think it looks really detailed, and because we also have this scale bar in view, what you can see I'm doing here is I'm putting in a measurement between the 2 dots and the centers, and it should be around 50 centimeters. So that's pretty close. So what we actually achieve is a 3D point cloud that has a very high relative accuracy. Of course, we would also like this to have a high geographic absolute accuracy. So what could be the second step is to, of course, measure these GCP markings. So use whatever preferred survey equipment that you have, and then measure these GCP markings. I think important is to note that this could both be done after or before video recording. And I would like to make a point that maybe this could make for some interesting workflow, because of a traditional workflow, when you have installed your pipes and your own excavation, you kind of have to have a surveyor coming out and survey the pipes before the excavation is getting closed. And for that, it can be a bit inflexible because they can have a lot of waiting time in between. With SmartSurvey, it makes it possible to have another workflow where you could actually, as long as you have marked the GCP markings and have video recorded, you could actually go out afterwards and measure the GCP marking. So this, for example, is from another site where we went out the next day, and okay, you maybe don't want to wait a week because then the markings will be washed away, but it is actually possible to go back and measure these markings again. So that is for sure something that is also an interesting aspect. The next step is really then, now we have your coordinates, your GCP markings, and what we have done is that we have, this is from point view, where our video ends up from SmartSurvey, and here we do what we call pick a point. So we georeference all the coordinates to the image of the to the image, and by doing that georeferencing, we end up with a georeference 3D point cloud, and that is at least one way to do to end up with the result of a georeferenced 3D point cloud. I want also to mention something with the best practice of video recording. So here we are at another site with a pipe laying trench, and how you video record and what kind of phone you use definitely also matters. So I have taken here 2 cases. One is with a budget smartphone, the Samsung A series, where I only did one walkthrough down the trench, and the other I have an iPhone X. Not a really, it's not so much a high-end phone anymore, but it certainly was high-end for 4 years ago or something like that. And then with the iPhone, I walked around the pipe trench. And what you also see is that it certainly had a lot more images and also from different angles from the trench. And here's the result. Not because I would say either of these point clouds are bad, but I think it's very visually. It is for sure that this one on the right side is more high quality, and the fidelity is better of the point cloud. And also notice how if you don't, the thing with photogrammetry is it only captures what you record, right? So if you don't get it from a certain view, you will not have that ending up in your 3D point cloud. Okay, so you have probably also seen the teaser video from this workshop, and here there was this smart external GNSS antenna attached to it, and this is also something done. This is something new we have done here with SmartSurvey. So we tried to see, could we even make it even smarter? So what we did was that we have used the Trimble DA2 antenna. Of maybe some of you know Trimbles, but it's it is a high quality GNSS antenna, and it works with the Trimble Catalyst system. So just as I showed here in the video, we now combine both the video recording together with a 3D path we track alongside the video, and the end result is the same. We end up now with a detailed 3D point cloud that is also georeferenced. So this is maybe a smarter workflow. Indefinitely in terms of improvements, I would say it's a faster workflow. You don't need the GCP marking stuff, and you don't need the manually work of doing a pick and point. And I would also say it also has less human errors because it's less manual work. And we actually also see it is more accurate if, of course, if the GNSS signal is good enough. But if it is good enough, we take many more position coordinates along the video paths. And the last thing I just wanted to say was that this is now working together with the Trimble DA2 antenna, but we are also expecting to support more antennas. So this is really exciting what we are trying to develop here, we think. And you probably also want to know about accuracy, right? You have now I talk a lot about trying to get to relative good accuracies. So we did some accuracy evaluation also. We did a test on some point clouds between 1 to 20 square in area size, square meters in area size, and of these point clouds of water pipe trenches, we marked a marker on the physical pipe as a checkpoint, and we measured that checkpoint and compared it to the virtual coordinates. Here was our results. We got a root mean square error between around 3 centimeter So I think we are like very comfortable in saying that also over other uses of this that we see an absolute accuracy around 2 to 4 centimeters. It is, of course, again, depending on how well the survey equipment you have used for the GCP markings and how well you have done the pick and point precision. Again, I would also say that the relative accuracy, so for doing like measurements inside the point cloud, the relative accuracy is we get that, you know, we can get that below 1 centimeter if we use the scale bars also. And also just mention that, so this was a test done with the GCP working flow, but we have also, of course, done a test just now with the Trimble DR2 antenna, and we get a similar result, if even better. Yeah. So what now after surveying, right? So SmartSurvey was developed together with utility companies in Denmark. So there was really also a focus on what to use it after surveying. So for mapping, and what we have been doing together with the utility companies in Denmark, that Michaela, she's one of them, the last speaker, she'll talk more about, is this how we digitalize inside the 3D point clouds. So we actually do the traditional utility mapping inside the point cloud, and then we take this vector line we draw on the point cloud, and we can then directly import it into our GSS system, whatever the system the utility companies are using. All right. Okay. So the last thing is just I wanted to like recap, you know, why we do this, and I want to use this Mr. Incredible meme that I like very much, because it's described the cycle of an utility, right? So the installed utility, like in the physical world, that's Mr. Incredible. Then it go through this data quality loss process. So maybe the contractor doesn't deliver all the information, and then it comes, and then everything is flattened into a map and becomes this utility map, and then afterwards we take the utility map and spread that onto the surface again, right? So if we really look at it, I would say that what we are doing with traditional surveying and producing maps is really just taking information and representing this representation of Mr. Incredible. And what SmartSurvey does is really try to store the actual 3D representation of Mr. Incredible as a 3D documentation source. Yeah, that's it from my side. Any questions? Yeah.
1 minute.
I'm Mark Wengta from SISV. From your trial run for the 20-meter videoing and capturing, what is the total storage space, and how much time you need to take from the data you captured to process it to what has been the drawing and all that? Because we always know that field work is always one time and the office spec is always more than 2-3 times. So from your current example, can you highlight to us on this issue?
So the time we do for work when it takes from processing the video into a 3D point cloud, for that it usually take only 10 minutes, but it is of course also depending on how much. If you send like many videos at the same time, it will take up, it will stock up in the queue, and it could take some longer time. But around 10 minutes, and from video to 3D point cloud, that's how long it takes.
So you actually have own customized software to do that?
Yeah, that's totally that's automatic from like the video into a point cloud. But of course, that's only the relative accuracy of the point cloud. Then, of course, also if you need to do this georeferencing and pick a point stuff that I showed, that also takes up some more time. And yeah, I'm not the one doing it, so I think I cannot really estimate how long time that takes. But it is certainly also some time. Yeah.
So would your point cloud be exported as a common IFC?
The point cloud will, when it's available, first it'll just be available in like the web browser, so it's easy accessible in this point view web browser. And from that, we allow to download it as a LAS file. So that, yeah, you can just download it and, yeah, load it into your own system.
Okay, thank you.
Welcome.
You'll get the mic. Yeah.
Hi, I'm Clifford from Liebenhaus Surveyors. Just want to ask, what are your limitations of this app? It's like what's the area? Because your test is only up to 20 square meters. Is that the limit or?
Yeah, good question. Yeah, so it's really designed around water utility companies in Denmark, and what they wanted to use it for was, you know, when they do water excavation rework. So when there's a new an old pipeline that should be maintained into a new one, and that usually is, you know, smaller excavations between 1 to 20 square meters. But I don't think it has any limitations in regards to how much it can scan. Of course, if it's like, there is challenges, of course, if it's like, for instance, a sewer project that is much larger, and also if it's much deeper, the excavations. What we have experienced is that really the newer phones, which has better camera quality, really does a good job, even in excavations that is like really deep, like down to 6 meters. We also get good results. But yeah, but it is, yeah, it is relatively, it is versatile. We also done like scans of a building with this. It's basically just, you know, respecting, you know, the, what you said, the process of photogrammetry. Yeah, so how you move you do your movements and make sure to cover it from many angles and stuff like that.
Thank you. Any other questions from the participants? Rob, is there any questions online?
Yes. Good afternoon, everyone in Singapore. Yeah, there are a few good questions coming from online. So I just sort of ad hoc established that we democratically upvote the best questions. So let me just start from the top, and then Bara, you just have to stop me when the time is over. Okay, so we just try and address a few good questions. Perhaps one that is really good is a good question is from Kin Wang, is whether or not extracting features of interest from the point cloud data, whether that is still something that is to be done manually, or is this already done automatically?
Yeah.
And how would that work?
I guess yeah, that's right now it's just manually. So for instance, like if there's a pipe and we want to draw a 3D line on top of the pipe, like indicating that feature, we have that is manually. So we just have like basic drawing tools like make a point and a line and a polygon, stuff like that. But it is something we're looking at doing this automated. It's actually something that my postdoc project is looking at, automatic feature extraction. So yeah, stay tuned.
Must be the holy grail, I'm sure. Okay, another question rising to the top. I think this is one that is very relevant to the practices in the field. How does the video capture the depth of the trench and the pipes? So I think not so much absolute height, but maybe depth relative to the surface.
Yeah, depth. Again, like, because the most thing I will see the best results is, of course, on these excavation holes between 1 meter to 3 meters. We really get like quite comfortably good results. And we have also tested on deeper excavation holes, so for instance, a sewer project like down to 6 meters. And we, again, surprisingly see good results, but you know, there's challenges, for instance, lighting become maybe darker and stuff like that. But again, I would say it's really remarkable how, you know, much an effort or how much a difference it makes to have these newer generation phones with better camera sensors. Yeah, so, but it is, yeah, that's my answer. Not, yeah, maybe a political answer.
All right, I think I have 2 more questions from the audience. One that I want to raise is from Roy. Roy asks, how does the use of videos of various grades of quality or the use of different hand phones that maybe have different cameras, how does it affect the measurements? Maybe you would recommend only to use a particular brand or type, or maybe a minimum resolution, for example.
No, I don't think. I think what we experience is that definitely phones with good video stabilization is a benefit for us. But we are always like, we have been tweaking our algorithm to like also, you know, don't detect. We don't if we clip the video. So if it's a blurry image, we don't take that image, and then we take another one. But I would definitely say that video stabilization is a huge factor in getting a good quality model. Yeah, and you could even also done tests where you maybe, you know, if video stabilization can be done digitally, right? But you could also use, you know, it's called like a pole that do stabilization, and that we also seen that produces better results.
Thank you. So yeah. I think one more question from John, who I believe is calling in from New Zealand. And the question, I'll just ask the question first, and then maybe I want to say something about it. So the question is, how does SmartSurvey compare to a solution like Pix4D? So we will learn a lot more about Pix4D, I think, in the next session from Shane.
Exactly.
So I think John shall be able to make a good comparison. But maybe for you, Lasse, because you know, you are with IT34, but you're also a researcher. Like, how do you see the technology landscape? What are the types of solutions and the differences between them? What do you see on the market?
I think there are other solutions like you know, there's Pix4D, there's Arus, there's other. I cannot, I don't have a huge list of them, but I think someone take different approaches. I believe the Pix4D together with the VDOC is like a very all-in-one solution, where our approach was really take whatever phone you have, so focus on versatility, for the guys in the field, that they could just have whatever phone they have in the pocket, turn that video into a 3D point cloud. So I think different solutions comes from different needs and directions pushed by, from our side, it was really a co-cooperation between clients and stuff. So that's what started our development of SmartSurvey. Yeah. So I see different directions, but going in the same direction, sort of. Yeah.
Yeah, really good answer.
Thank you.
Thank you, Lasse, and Bharat, over to you.
Yeah, thanks. Thanks, Rob, and thank you once again, Dr. Lasse. Now it's time for polls and for some brainstorming discussions. Back to Mentimeter. Yeah, I hope people are ready with their Mentimeter on their handphones. Yeah, so here comes the question. In your opinion, what are the benefits of 3D reality capture? So there's no right or wrong answer. This is an open-ended answer. Feel free to type your thoughts. Convenient, yeah. Data rich, agree. Archiving, yes. Cool. I think Lasse would know how hot it was to capture. Yeah. Good. I think the screens were flowing with answers. But yeah, it's good to see people having their thoughts pouring here. Thank you. So now let's go to the next question. How could 3D reality capture contribute to the subsurface utility surveying and mapping? It enables faster surveying and mapping. It lowers the cost of the workflow. It results in more accurate data. It results in more reliable information. It unlocks new use cases of the data. It increases accessibility as a broader group of users can perform the task. Again, you got max almost I think people are agreeing on average 5. Okay, I think people are more towards this technology. They are towards agreeing and strongly agreeing. Good, thank you. I think all the above answers are correct in one way or the other. In fact, we as SLA and the registered surveyors who are here in the session know the pain of capturing accurate data and the cost involved in capturing. Thank you, Dr. Lasse. This is an interesting piece of research work. Now we have our second speaker who comes more from industry practicality perspective, Mr. Shane, on the topic adoption of reality capture solutions for open trench mapping. Welcome, Shane. Mr. Shane Shi is the Managing Director of HSC Pipeline Engineering. He graduated from the National University of Singapore with Bachelor's of Engineering in Mechanical. Since 2011, he is in charge of multiple digitalization efforts at HSC, spanning across multiple departments from HR, procurement, finance, safety, and operations. Using available technology, he had successfully pushed HSC to the forefront relative to the peers in the same industry. On the side note of the records, his company is listed in the Hong Kong stock market. So based on his presentation, you can turn out to be an investor by buying his company stocks. Welcome, Mr. Shane. Over to you.
Thank you. Hi, thanks to Digital Underground Connect to invite HSC to present today. To be honest, I think I come from a contractor background, so I'm actually much more orientated, money orientated. So, and it's also a lot to do with, cost efficiencies and the process flow. So today I'm just going to talk about, the adoption of reality capture solutions, for open trenching mapping. So HSC Pipeline Engineering is actually a trenching contractor. We have done this for 30 years. We have been doing gas pipe, water pipes, utilities in general. So we are very familiar with the cut and cover and the issues that's surrounding this particular, activity. So we're just going to quickly run through the problem, the solutions, and some of the advantages that we see in adopting reality capture. So I think our peers here will be very familiar with, trenching on the road type of activity. It is crazy because in a construction site, maybe 8 o'clock we can start work. Then we can continue to work maybe until 8, 10 o'clock, depending on the site, especially, for example, in developments or HDB developments. But when we talk about LTA roads, it's a totally different ballgame, because if 8 o'clock, when you're driving to work, there's a contractor blocking the road, the first thing you will do is you will call LTA. Hey, the contractor blocked the road already. Then at 5:30 or 6 o'clock, when you're driving back from work to home, then suddenly you see another contractor blocking the road. You also can call LTA. Hey, this contractor is still working on the road at this hour. Okay, so we're actually bounded very strongly by the road opening hours, which is 9:30 to 5. Of course, we're not talking about night first. We're just talking about day works, which is very typical. So 9:30, we start to close the road. Between 9:30 to 12:30, short 3 hours, we have to do road cutting. We have to take out all the pre-mix, graded stone, quarry dust, dig until the depth. And for SP, lucky better, 1 meter we need to push shoring. Oh, die. So many things to do. Okay. So then between 12 to 4 to 2, then we will be doing pipe laying. We're joining all the pipes, pipe fusion, electrofusion, joining, coupling, whatever, right? Then we actually need to start to do backfill at 2 to 2:30, graded stone 2:30 to 3:30, premix 3:30 to 5. By 5, we have to open the road. If not, 5:15, LTA with their smart camera, they can see us. Then they call us. HSC, why you haven't opened up the road? How long are you going to take? Blah, blah, blah. And within all these activities, we are so packed already, right? Then we need to do survey. Right? Then suddenly you get surveyor team that is on the way. But we cannot wait. Sometimes we cannot wait. So, and then often it's like, by the time they come, maybe we backfill some of it already. We only left like the head, the tail, and maybe the fitting so that they can survey. But that isn't the full information that we capture. And even when the surveyor team come down to site, it's very typical that they will need the total station, or they need a GNSS, they need to get the satellite data there. Then before they start to survey, because they need to get reliable data to produce a reliable as-built. So again, it's really a mad rush for work. So then there's a lot of friction between the survey team and the excavation team. And we know that once we backfill, that's it. You won't be able to see it anymore. So sometimes we take a lot of photos, sometimes we do site measurements for the survey team for their record. And it's very typical in a surveying type of context that, number one, traditionally, let's say talk to the station. Okay, to the station, you might not even have a control point nearby. So maybe we need a GNSS nearby. We set up the control point. At the bare minimum, we pack the 4 points of the trench, whether it's the pipe laying trench or whether it's the trowel hole trench. Then we pack the additional points that we're interested in. So very simple, services, we pack the center, right? If there's a trowel hole, there's services inside the trench, then we pack the services. But meanwhile, because total station cannot shake cannot see, right? So we have to stop the work. We cannot have excavator moving. Sometimes vehicle, when they're moving, is also contribute to a longer surveying time. Then step 3 is very simple. Once you collected all the data, we bring back to office, the draftman's problem ready. Okay. And the survey manpower, not including drivers, not including transportation, the survey team minimum two person, one with the station, one with the ruler, right? And then we extrapolate this issue. This is even bigger issue. Every survey team every excavation team actually need one survey team, because right now I only have 2 o'clock for you to survey. I cannot hear 2 o'clock, the next team 3 o'clock, the next team 4 o'clock. And we cannot say, 9, 10, 11, 12, one survey team to 5 excavation team, no way. So effectively, we actually need one survey team to one excavation team. And in today's context that we have severe lack of manpowers and severe lack in trained manpowers, actually this is a very big issue, right? And so the solution that we realize is there. It's just that we need to look for it. So under SL Code of Practice Standards and Specification for Utility Survey in Singapore version 1.1, as-built surveys actually can be done performing total station, something that we're very familiar with, GNSS RTK, also familiar with, and 3D laser scanning. So this is what we are using, as in we came to realize that this is a very good solution. Number one, we use iPhone 12, but please make sure it's the Pro series. Okay, I will explain a bit more. We use the ViDoc. We use Pix4D Catch / Pix4D Cloud, and one man. Okay, so what is this combination? We are still using photogrammetry. We are still taking photos, capturing the data from there. We are using the ViDoc as the GNSS RTK that give you the geolocation, and we are using LiDAR points, meaning that when the iPhone 12 Pro series, they actually have LiDAR, so they actually combine these 3 data sets to give you a very highly accurate geolocated point cloud. Okay, and you will be able to see something like that. All right, and we'll explain a bit further, but you can see this is a one-man operation, like SmartSurvey, similar to that. So now then we change our processes a little bit. Right now, instead of setting up control point that might take some time, we just check, turn on everything, we check that, okay, this one satellite signal is okay. Number 2, we capture, we walk along the trench, right? Then but work don't have to stop. Step 3, finish already, same. We upload to point cloud, then it's the drafter problem. Okay, then we pass it back to the drafter. And I think the best part is here, is that, you know, in survey team manpower wise, we actually just need one. So imagine now you have 2 techs. You can separate into 2. You can have 2 teams. So that is very cost efficient for the survey teams as well. So this is how the thing is done. So same trench, same site. Actually, both of us use the same time. So we just capture along the trench. And it's done. And the good thing about Pix4D Catch is that when we use Pix4D Catch, there's some visual elements inside the app itself that tells you that the point clouds are being captured. So you'll see this cloud that slowly backs away. Then you know that this part is already captured. You're safe to carry on with the capture. And it's actually geospatially accurate. I mean, given this setup. So we can zoom into location. The location actually you can see in the street view, satellite view, and you can also know, I think, yeah, okay, the next one, sorry. So this is topography. That means when we click, okay, Northding, Eastding in Singapore context. So there's no conversion that's needed as compared to, you know, if you're using long leg type of systems. And measurements can be done, meaning that measurements in any part of trench that you need, you can click from the point cloud, the point on top of the road to the point on top of the pipe, and you got a pipe depth, right? If you click from the start of the pipe to the fitting, for example, you know the length of the pipe, or to the joint, you know the fitting, the length of the pipe, and this gives us a very comprehensive point cloud that we can use, and we can extract a lot of data from here. And for reality capture, I think the best part is that in the bigger context, when we excavate, we will start to see a lot of services crossing, and we can capture this to you know, better update certain services plan and utility maps as we go along. So you see all the lengths, all this is there. Okay. So seeing is believing. That's Kenneth from eSpec. He's the one that's carrying the product in Singapore. So if you are interested, definitely please scan the QR code. You should be able to see some of the trial trench reports that trial trenching that we have scanned. Okay. So we can measure, areas. Some contractors, some clients, they like to see, what's the volume of excavation, right? Then you can do this. They want to see what's the area they excavate. You also can do this. So it's something that is easy to do, and this is less. In my mind, is much less intensive to the guy that is capturing a point. Maybe they miss certain points or this. Now we capture, we bring back to office. You want to check any point, it's also possible. So advantages. So this is just making real business sense. Okay, traditional total station can cost something like 30 to 50K. This is something that is open to everybody. Nothing hiding. I mean, of course, you can use the Rolls Royce of total stations. All this is up to you. Manpower typically 4K inclusive of everything. For example, levy, blah blah blah. So they will cost you about 4K each. And if you take 2-man team, times 8K, that's 96K. 96K plus 50K, that's on the higher side is 140K annually. If you use reality capture, right now what we saw was, for example, our setup costs about 12K. Right? 1 packs of 4K, 4 times 12, that's 48. 48 plus 12, 60K. So you have 60K compared to 146K. So that's like first year. Second year, you actually technically do not need to pay for the equipment anymore. And again, your 2-man team become 2 1-man team, double the revenue, right? Yep. So that's the end of the presentation. I'm more technical. I'm really more to the ground, to talk about what's realistic on the ground and what's whether we can make business sense out of reality capture. Yeah.
Thanks, Mr. Shane. Questions from audience? Rob, are there any questions online?
Yes, there are. There are 2 questions here. I'll just read both of them out. They're somewhat related.
Yeah.
First, a question from Brian. Brian asks what RTK correction is typically used. Using a CORS or SLA Siren or something else. And the second question is by Roy, asking how well does VIDOC RTK function under conditions with multipath LLOS effects. In other words, is there a fallback option in case positioning from the GNSS is not precise enough? Is there an alternative? Those are the 2 questions.
Okay, so we can, I think we tried to, one was it to tap onto the SLA Siren system, so that one works perfectly. The other system I can't recall for now. We can let you know after this, but basically so far both systems has been working for us fine. Second question is law of sickness. Okay, in Singapore context right now, we tested it multiple areas. We went to Tuas, we went to Changi Airport, we went to CBD, we went to HDB. So the only place that we really have an issue is actually CBD. Very simple reason. The buildings are very tall. It's affecting the satellite signals, so you can't get a very good satellite log to that. So for that particular context, for quality, we will actually just recommend to fall back onto traditional surveying standards. That means that, again, to set up control points and to throw points, or to use GNSS and throw points until that particular trench. But if you look in the bigger context, like the whole Singapore, then the CBD is actually a very small area as compared to the rest. So your use case is still, maybe I would say 95% okay as compared to the 5% in the CBD. And in perfectly honest, I think in CBD, utility is really maxed out already. So the amount of work that you can find in CBD is also kind of limited at this point in time. Do you have a question?
Yes.
Yeah.
Hello. Yeah. Yeah. I'm Otto from Reduct. Probably a stupid question, but does it work at night, or do you need extreme lighting to get it captured properly?
So far, we can't work in the dark as well. So in excavation, we usually have our tower lights on site. It will still be somewhat illuminated. So far, the data that we capture at night is still reasonable. It's something that is still in what we see. It has not deviated too far just because of low light condition. But again, we are not capturing in total darkness. Okay, I can't say for that. I only can say that now with tower lights and some excavator lights that is already on the site with the street lights, actually the capture has been quite consistent. It's not deviate from the daytime. We don't see any difference. Yeah.
Any other questions?
I have one more from
Rob,
the
any other
audience.
questions in online?
Yeah. Yeah, there's one
Yeah.
more question from LSGMW. I'm sorry. So the question is basically about what happens below, right? So I think the technician, and this goes for the SmartSurvey as well as for the Pix4D workflow, the technician captures the data without going down into the trench. Would you still have enough point cloud or detailed information to assess the bottom part of the pipe or anything that is below?
Okay, so like most survey, we actually pack the top of the service, right? Then we do a record. What size is this particular pipe? And that's how we say that this bottom, what's the bottom level of the pipe? We don't, I mean, even in surveying terms, we do not go down and peg the bottom of the pipe. Nobody does that. So to begin with, I think we are kind of in line with what traditional surveying are doing, which I think that, really, again, this is much easier. We just need to make sure that satellite signals are there, we capture and it's there. And then again, there's some visual for us to see that the point clouds have been captured for this particular stretch. Of course, where the light don't shine or where there's no direct line of sight, it's really difficult for any technology to be able to go until there. Yeah, so I hope that answers the question.
I believe it does. So it's in line with the survey standards. So if anyone would want to maybe inspect the bottom of a pipe and use that technology, obviously they would have to establish a line of sight to also assess that. But in Singapore, we survey the top of the pipe at the moment. Let's see. Let me see if there's another question. Maybe just a question from me, Shane. You're a money man, as you said. So can you maybe share with us a bit? And I guess the stocks have already been bought, right? So we're now at the peak. But anyway, how has this impacted your business? Is there anything that others may want to pick up from this, as a business opportunity?
Yeah. So like what we mentioned, in construction, especially for utility engineering, there's two things that is kind of important to us. Number one, it's the hours that we have. So the hours that we have is non-negotiable. You can't tell LTA that hey, I'm waiting for survey team. No such thing. I also cannot tell. Honestly, I also cannot tell them that my premix haven't come. To LTA, they ask us to go and fly kite. So time is of essence. So we cannot cause a dispute between the survey teams and the excavation team, because that will also create friction in the very long run. Second thing is that so number one, when the survey is fast, then that also mean that the project team is more willing to work with the survey team to wait for that 5 minutes. You tell them you wait for 5 minutes, I capture 5 minutes, everything's settled. They will be no problem. You tell them, hey, I need maybe something happen, I need 20 minutes. That causes a lot of friction. Second thing is that again, we saw that the survey teams dropped from 2 men to one man, and suddenly with the same manpower, they are able to run double the sites. Of course, transportation aside, because transportation, it could be Grab, it could be anything else. But if we realistically talk about the number of team, you double it. And by numbers, assuming we're charging the same amount per survey site per day, then you got double revenue. So for survey teams, that will make perfect sense for everyone.
Any other questions, Rob?
One more question. How much effort or time was spent training your surveyors to use this technology?
Yeah, so the training, because most of the images and to verify that it's working, it's all on the handphone. So and into this context, even down to the supervisors, the Indian workers, they actually know how to use handphone. So they are very good at TikTok and all these type of things, right? Where I also don't know how to use. So they actually can just tell them, oh, you need to look out for this satellite signals that is okay, right? Then when you scan, then visually it's okay. As long as the trainer know how to train them properly, you can verify the information back to that. I think the training takes like half a day, to be honest. I think Kenneth took 1 day, half day for theory and half day for actual sites and multiple runs to make sure everybody knows that it is they are trained enough to use the equipment. Yep.
Thank you. Bharat, over to
Thank you. Thanks, Shane, for the power packed presentation.
everyone.
Now we understand you more and hence can appreciate your initiatives. Thank you.
Yeah.
The audience, we are midway through, and I hope you are enjoying this session so far. Let's take a short break and meet again at 4 p.m. Thank you. See you back. Okay, welcome back. I hope you all had a break and feeling energetic to poll your votes in Mentimeter again. Let's take your hand phone and please be ready for the questions. Ready with Mentimeter? Yeah, I can see some likes. Yeah. So this is the first question. What are the key challenges that must be addressed to further uptake and implementation of 3D reality capture technology? In this open-ended answer, please feel free to put your thoughts. Funding, yeah, of course, money matters. True. Cost and training, agree. Regulations, yes, of course, important. Change in mindset, good. Proof survey grade, yeah, that's something which is the need of the hour. Availability of good equipments, data sharing, yeah, that's always a concern. Good. Data integration, cost and benefits. Agency, SLA, mandate and provide funding. Oh, great. Okay, thank you. So now let's go to the next question. How would you rate the following challenges towards uptake and implementation? So these are the challenges. Reliability. 3D reality capture is not a reliable surveying method. Data quality. The resulting data is not sufficiently accurate or reliable. Capabilities. There is lack of skilled professionals that can produce, manage, and use the data. 3D readiness. Asset data management systems need to be able to ingest, store, and deliver 3D data. Demand for 3D. Applications and use cases of 3D data need to be sufficient and well-defined. Governance. A regulatory framework needs to be in place that clearly defines roles and responsibilities and endorses the technology. I think these are the points which were coming in the previous question, and time for you to vote. Very important to address. The topmost are maybe 3D readiness, demand for 3D. Yeah. Only if there is a demand, there will be a supply. Governance. Okay. I think the 3D readiness is something which tops the pool. Okay, good mix of answers. Anyone would like to compliment, agree, disagree with these responses? Maybe regarding data quality, I think we have got Maria here. Maria, do you think there is a gap or scope of improvement in the technology? Maria, to you. Yeah, you'll get the mic.
Hello, everyone. So you're asking about the gap in the technology development, right?
Yeah.
Well, I think the gap is, I guess, as the technology develops, the gap will always be there, but it's always a new gap, right? So technology is continuously developing. So yesterday's gaps is, today's solution, and then there's new gap every now and again. So it's difficult to pinpoint a particular gap, I would say.
Agree. Yeah. Thank you. Thank you. And the other question is about the capabilities. I think even Shane was mentioning about the lack of skilled, qualified professionals. Any registered surveyors were here? Maybe I can name maybe Mr. Chia Ekok. Maybe if you want to attract more talents, what can be done from the government side? Chia Ekok. Give me a minute. I'll pass over the mic to you.
Yes, I think it's a well-known fact that in Singapore there's no institute that provides training for. Even Polytechnic has stopped the land surveying course for a long time already. So we are now taking in a lot of graduates from Malaysia, and my company took in a lot from China. So we will need these people to be able to assist us in the processing of the data. Field research is fast. It's quite simple with all these advanced instruments and all that, handphone. But the geopositioning is actually what the surveyors are sort of good at. That's what we specialize in, defining the position. So without all this geopositioning, and the data actually can be quite dangerous, I would say, because you put it in the wrong place, and then an excavator could easily burst a pipe, that sort of thing. So I don't know, but I have managed to get some of the surveyors who graduated in China to get PR, because the argument that Singapore doesn't have a course is a very strong argument. But no, in time to come, maybe when the government look at education as a business, then it's not cost effective to run own course, but somehow we have to get people to come and more people come, perhaps to take the board exam and get qualified, because I'm quite sure that Mr. Mark would know that the average age of the land surveyors are in the 50s, yeah. So we actually need young people to come and take over.
Thank you, Chia Eko. Yeah, so now let's move to the next session. And here comes the third and last speaker of this event, Miss Michaela, speaking about 3D reality capture for subsurface water asset management. Michaela, can you hear us?
Yes, thank
You're
you.
on mute. Yeah, okay. How are you
Can you hear
doing?
me? Fine, thank
Good.
you.
How is the session so far? Are you enjoying?
I'm enjoying. I just came in 5 or 10 minutes ago, so but
Oh, okay.
interesting.
Okay. Good.
Yes.
Good. We both are related in a way. I too belong to the water and GIS community of practice. Nice meeting you. Okay, so now I would like to welcome Michaela. So she's a project manager for water supply assets in Danish utility company Kalundborg. She has 20 years of experience within disciplines such as water supply, strategy planning, GIS, asset management, digitalization, and optimization. She has helped to implement many new geospatial technologies within the Danish utility companies that she has worked so far. Her latest focus has been on utilizing 3D reality capture solutions for more comprehensive documentation and management of underground utility assets.
Yes.
You can start sharing your screen,
Okay.
and
Yeah,
I'll let you know once if it is visible to us. Over to you, Michaela.
Thank you. You can see my screen now?
Yeah, we can see your screen.
Okay, thank you. Yes, thank you for your interest and inviting me for this digital underground connect. Yes, as you told before, my name is Michaela Bloch Eiris. I have 20 years of experience working in Danish utilities. Now I work at the Kalundborg utility, which is a smaller utility. We supply our customer with water, wastewater, and district heating. I have the last 5 years participated actively in the development and implementation of point clouds. I have been given many presentations about how I implement point clouds, but never in English. So let me know if some of my points is not so clear to you. Yes. When Lasse was doing his research work, he brought the 3 utilities together and formed a group that discusses the spread of point clouds in utility companies in Denmark. The 3 utility companies are Aarhus Utility, Novafos, and Kalundborg Utility. Novafos and Aarhus utilities are big companies in a Danish context. Novafos supplies about 100,000 customers, and Aarhus Utility about 350,000 customers. Kalundborg Utility is a small utility which supplies about 6,000 customers. All 3 companies supply their customers with wastewater, water, and Kalundborg Utility is the only of the 3 companies which also supplies district heating. It is some of the points from the discussions from this group I will bring up in this presentation. So, how do utility companies work with the point clouds? I have illustrated the workflow in these 3 pictures. So, first we film the open trench with SmartSurvey. It is our own operation crew who makes the film with their mobile phone using SmartSurvey. The film is made in connection with the completion of their construction work in the field. So we have no delay waiting for another person doing the surveying. Second, we use the point cloud to digitalize the pipes, valves, and other components. The digitalization is registered in a traditional GIS file. And as shown in picture 3 here, the GIS file is loaded to our GIS database, and we now both have a traditional GIS registration and the point cloud. So the point is that we no longer use traditional survey. We use the point cloud to make the traditional utility registration in the GIS database. All point clouds that is generated with SmartSurvey is automatically available to the organization in the utility. And this is a very important point in implementation, that data is available to the organization. And I will now show you how NovaFOS uses their WebGIS solution to display their point clouds. So I will go live now and show you. Just do this. So what you see, I hope you can see the WebGIS solution now. And as I told you, this is the NovaFOS WebGIS solution. So they have the classic traditional water supply registration here. And they also have the point clouds. It's a little bit small. I can go a little in it. I can zoom in now, and then we should come to the bookmark. Just 1 minute. It does. I will zoom in here, and we will see the point clouds. So this is a project where they have done some renovation for the water supply, and here you have all the point clouds here. And to see the point clouds, you have to click on the polygon, and you come into the point cloud. So now the point cloud is loaded into the viewer, and it is always this viewer that is used to view the point clouds. NovaFOS has about 6,000 point clouds, because they have decided that all open trends should be filmed, and they make these point clouds of this. And the last 4 years they have been done that. So now they have about 6,000 of these point clouds for their water supply. And this is one of them. So this is the viewer they always use to look at them, and they can panorate and look at the point cloud. I think Lasse showed you that before. It's the same. They also have some tools available. This tool about measuring tool is the most used tool in this viewer. And it is used to measure. They can see can place this and see the coordinates, whatever they want. They can measure the distance and the height. And I think these tools are used very often in the organization. And they know how to use it now, because it's the same viewer every time they open the point view. It's this viewer they get. Another tool that is used is the drawing tool. And as I told you, we have people who is digitalize the assets, and they use this drawing tool, and they go in and make. See, they digitalize the pipe here, And now the pipe is digitalized, and they can export it here as a GIS file, and then afterwards import it in our GIS database, and then you have the traditional GIS registration as I showed before. This is how we use point clouds for the water supply. I also has an example from wastewater. Yes, it's the red one here. We have this point cloud I will show you now is not from SmartSurvey. This point cloud is made from laser scan, and the reason for that is that we often have in wastewater, we often have very deep trenches and dark trenches. So SmartSurvey is not good for that. So we use laser scan to scan our manholes, and this is an example. Again, the link, and we get the point cloud in the same viewer. And this is a manhole for wastewater, and again, panorate, it's the same. You can go into the manhole, and you can look up the data you want. I can show you. I have to panorate. Just 1 minute. You can see here we have the pipe from the, oh, sorry. Go into the, yeah, I got that. And you can get the same data. Again, measuring tool. And again, this is very often used to look up some data about coordinates in wastewater. And you can measure the diameter of the pipe, also very used. So we also have documented many of our manhole in this way for wastewater. So it is very useful for our staff in the utility. Yes. So this was the NovaFOS WebGIS solution, and I will go back to the presentation. Yes. So what are the benefits for using this point clouds? I see some related to documentation of the construction work in the field. We can check that the installation work has been carried out correctly. Our operation manager looks through all the point clouds to check the construction work, and they find errors. And they can check that the distance requirements to other assets is complied. Sometimes there is a disagreement about if the distance requirements are met, and the point cloud is a great tool in this context. The point cloud can be used to estimate the amount of soil and the size of the trench. Sometimes there is a discussion between the utility and the entrepreneur about the amount of soil and the size of the trench. This is a money question, and the point cloud can often clarify this. So, yes, after implemented SmartSurvey, we are able to cover the trench faster because we do not have to wait for a surveyor to do the surveying. This benefit has been one of the most important reasons to implement SmartSurvey. Point clouds is a supplement to the traditional utility registration. You can measure and orientate yourself in a completely different way than in the traditional utility registration, as I showed in the NovaFOS point viewer. Information from the point cloud can be used for future design and planning, we can look up in the viewer and see all the details from latest construction. An example could be a backcasting, which often is not registered in traditional utility data. Another benefit is that this new data can lead to development of new solutions that benefits the utility, and I will come back to this issue later in the presentation. So, what are the challenges then? The best point clouds are made by daylight, as I showed you with the wastewater manhole. Alternatively, a light source must be brought along, and also the best point clouds are made when the trench is not too deep. Point clouds from water supply and district heating shows very good results because they often are placed in the upper section of the underground. And point clouds from wastewater can be a problem as it often lies deep. Yeah, this is some of the challenges I met in a Danish context. The benefits are not limited to the individual utility. Sharing point clouds could provide value to other asset owners in the underground. In Denmark, we have LER, which is a register of assets in the underground. In LER, all assets are registered by traditional mapping, and it is a legal requirement to obtain the information before working in the underground. Sharing the point clouds via LER will provide great value, and I will try to show you here. Here you see an example from Lasse's research work. The blue line and the green line, you see the information from LER, and the yellow lines is all the information that lacks from the LER register. And it is clear that the point cloud contains more information that is valuable for the utilities or the entrepreneur. So the point is that we have to share the point clouds, and I mean that it should be a legal requirement. Yes, as I told you previous, one of the benefits of introducing new technology like point cloud is that new technologies can be built on top of them. It is my belief that it will happen with the implementation of point clouds. And here you get two suggestions for this. One is reading of QR codes with SmartSurvey, and second, augmented reality in the field. And I will go into detail in the next slides. Yes. So, can QR codes be captured by SmartSurvey? We have investigated if it's possible that QR codes placed on the pipes and components can be read from point clouds. The QR code contains a link to an API to a catalog where you can capture information about the product. For example, information about material or diameter. This means that we can automate the process of getting attributes on our utility mapping and thereby expectedly increase the data quality. This project is in an experimental basis, but has great support among several water suppliers in Denmark. The last thing I will mention is to bring point clouds into the field as augmented reality. Again, Lasse has made demos of this, and in the pictures here you can see him presenting a demo for the operation staff in Novafos, and they think it's really cool. I will now show you one of Lasse's videos of this augmented reality solution, and the point cloud you see is from Aarhus Utility. Show you.
Corruption.
Michaela, can you hear us? You are with us online? Yeah. Michaela, can you hear us?
I can hear you now.
Okay. Yeah. So Rob said like if it would be good like if you can share your last slide because we lost you in the middle.
Yeah, I will share that. From where did you miss? Can you? Is it from here or?
A bit later. Here. A bit later. Yeah.
Okay.
Just go ahead.
So this one. Okay. What you see here is Lasse's augmented reality demo. So when you look through the iPad, you can see the point cloud. So my point is, the solution is really, really cool, and this is an example of how we can use point clouds in the future. So I think we should go out and make the data, and when the solutions are available in the market, we can use our data in this way. Yes.
Yeah, this is really impressive. Thank you. Thanks, Michaela. Yeah. Go to the audience for question and answers. Please raise your hands or type down on the chat panel. Anyone want to ask any questions? Audience? Yeah, Ken Hart.
Thank you, Michaela. I'm Ken Hart here. Yeah, I'm particularly interested in terms of the submission by the utility company to the national register that you mentioned here. Beside the point cloud, do the utility companies also submit like different features like the point lines, polygon to the national registers? Because I believe that the national register have to update their database because they are not able to use the point cloud just to update their database. They may need some other features like the point line polygon, which is maybe extracted from the point clouds. Can you share with us what kind of submissions, what type of the data that the utility companies in Denmark has to submit to the national register? Thank you.
All asset owners has to put their data into the layer. So that is water supply, wastewater, and so on, but only the lines, not components. Maybe Lasse, you can say a bit more about that.
I can do that. Yeah, I think also your question was from seeing her slides like that the sharing would bring value, right? And so right now we cannot share point clouds. We don't upload point clouds into our national asset register. And as Michaela say, it is now we are actually going through a transition in Denmark where layer is being upgraded to layer 2.0. So it's focused on uniformity. So everyone should share utility data that is standardized, but we are only talking about points, lines, and polygons, like into different types, so like into waters and sewers and stuff, and then also an agreed number of attributes that we have to apply to these utility lines. So very much traditional utility mapping data we are sharing. But yeah, I share your wishes or values, Michaela, that sharing point clouds could be interesting also. Yeah.
Thank you. So we have got one question. How do other asset owners in Denmark respond to your initiatives?
Oh, I'm not sure I understand the question.
Okay, if you want, I can repeat.
Yeah.
Okay, how do other asset owners in Denmark respond to your initiative?
What is the last word? What does the last word
Initiative.
mean?
Okay, sorry.
So yeah, what do other utility companies in Denmark? What do they say that you are now starting to collect 3D point clouds? Do they think it's a good idea, or are they skeptical? Or
Yeah. In the 3 or 4 years ago, they were very skeptical. They were skeptical about if it was correct actually enough, if the point clouds would do that. Not was correct registered, and we will get some errors in our registration then. But now many water suppliers want to hear about how I have worked with it, and they want to implement it. So I think the last year 5 or 6 companies I know have implemented SmartSurvey and point clouds, and I think that the value is when they see the value, they are excited, and so my point is go out and try it and see if it's useful for you, and if not, don't use it. So the point is go out and try it. Yeah, I hope it was answer.
Yep, thank you. Rob, do you have any questions online?
Yeah, let me raise one. First, I do want to say to Michaela that I'm just glad that we got your story out here. I think once again, we like to have people that share a story that's maybe a little bit people that have progressed a little bit further than what the mainstream is doing, and I really appreciate that. As you say, sometimes you just have to try things. You just have to maybe follow your heart and do what you think is right. And thanks for sharing that. I mean, the same goes for Shane, of course, as well, to take that leap. Sometimes that leap, it makes your work easier, or maybe it even saves you money, but I think it's important that we keep highlighting that, and I think as DUConnect in general, we will try that. Okay, there's one question from the audience about the storage, and I guess the question is what should be the way moving forward? We have the point clouds. Of course, point clouds are a relatively unstructured form of data versus GIS or maybe BIM data, which is much more structured or semantically rich. Both maybe for storing and sharing. What should be the way moving forward? Do we have to make a choice between unstructured or structured, or is it rather that there's value in keeping both around? What is your view on this?
I think we have to structure our data always. but it's difficult in the start. So we have to get standards, and we have to have standards also in how we store point clouds. We don't have that in Denmark right now. I think the standard is how we are doing it in Kalundborg and also in Novafoss and Aarhus Vand, as I told you here. But we have some challenges. For example, by how do we manage when we make a new point cloud in the same point? How do we manage the old one? And it is not. Yeah, so that is a challenge, and we have to have standards like we have it in the traditional registration. So I think the way is standards, but yeah, we are not there right now.
Thank you. We have got one question from the audience. Manshi.
Hi, Michaela. Earlier on, you mentioned that getting the point clouds for sewer manholes can be challenging. So I have a couple of questions. First is, what is the deepest manhole you have attempted? And second, are these point clouds done for sewers that are newly built but yet to be put in operation, or are they for sewers that are already in operation? Because the concern is for those sewers that are already in operation, chances of you getting the invert level will be low. Yep, these are my two questions.
Yeah, thank you. For SmartSurvey, I think the deepest hole is about 4 meters. When you use laser scan, it could be much deeper. I don't know what the deepest is. So I haven't seen a limit for laser scan right now. And the second question is, what was that? Sorry.
Were the point clouds collected for sewers that have yet to be put in operation, that is dry? Or is it in operation, that means the flow is already there and chances of you getting the invert level
that's right.
is low?
Yeah, you're right. But we do both. Most of the scan, laser scan I showed you before, it was a manhole in operation. So, but what you saw in the bottom, it was not very good, because there was some water in it, I think. So you're right about that. So in the future, we have to scan when we make a new manhole. That's a good point. But we think that the data we can get out of our manholes we already have is good enough, and so we do laser scan manholes in operation.
All right, thank you.
Thank you once again, Michaela, for joining us, and we wish you all the best and convey our support for your initiatives. With this, we have finished the presentation from 3 speakers, and we are moving to our last segment of today's event, the expert panel discussion. I would like to invite Dr. Lasse, Mr. Shane Shi, Mr. Mac Wang Tak, President, Land Survey Division, Singapore Institute of Surveyors and Valuers on stage, and 2 experts, Ms. Michaela and Dr. Victor Khoo, joining us online. Welcome.
Thank you. And I will be the moderator of this panel discussion. And what we actually would like to do is to kickstart this panel discussion with a last Mentimeter question. So everyone at it again, pull up the phones, go into Mentimeter. Let's give people some time to join again. Okay, let's try and see here. Oh, we already have, we should have reset it, right? Okay, sorry. So our first question was, who should be in lead to drive the adoption of 3D reality capture technology and 3D data? And we are now listed 4 stakeholders, so government, contractors, asset owners, or license surveyors, and also a 5th option, other entities. And if this is selected, we're keen to know who that might be. Okay. There's already, I think there's forming some kind of picture here. So we have government in the lead, asset owners seconds, okay. Contractors, license surveyors are battling, as they also are doing in the field. And then we have, okay, we actually have another entity. I'm actually curious to know who that is. Are there anyone from the audience here who has posted it? So no, it might be online then. Do you know Rob, who has posted the 5th option?
No, I asked, but yeah.
Okay.
I'm waiting for the person to collect all the courage and.
Or maybe it's just a troll. Okay,
yeah,
I think we have.
Yeah. Go ahead.
Let's start. I would like. So, what is the result now? Government first, asset owners, and then share the third fault with the contractors and license surveyors. Will you? Yes, exactly. That's what I needed. So we have now Michaela and Victor also joining. How is this easy for me? Maybe I should just sit here. Yeah. Okay. So, oh, I forgot my questions. Sorry. But let's start with the first question that was on the Mentimeter. So, government should be in the lead. That I think is a question for you, Victor. So, what do you think about this poll results that we see that the government should be in lead to push 3D capture technology?
So, thank you for the first question. So, in Singapore's context, it is always look like the government would take the lead. But having said that, I think for the digital underground project, we recognize from the very early stage that it is a very complex ecosystem. Government is not the only party that's involved in this, even though we have the intention, we really wanted to have, at the end of the day, reliable utility, underground utility information. We want to play the role of facilitating. That's the reason why you see a digital underground project, digital underground connect platform. To facilitate, to lead, we wanted to talk a lot about 3D. We wanted to show that 3D is important for many applications in future, for many smart nation application. And hence, we are pushing, we are trying our best to promote 3D, right? Including 3D point cloud, including the new 3D reality captures. And in the way we need stakeholders, in this case, the academics, the private sector, the surveyors, the contractors to come together. So we can take the lead, but we need the support from the rest of the stakeholders. That's my answer.
Okay, interesting. Yeah, so really, you're painting like it should be a joint effort, I believe. Maybe over to you, Michaela, because asset owners was the second place in the poll. So what do you think, was it natural for you as an asset owner to take the lead, because that's actually what I guess you did in your case with the companies you have worked with. Oh, you're muted.
Yeah, sorry. Yeah. I think it's the government who must take the lead for a national standard and for a national implementation, and that's my belief that we can do it ourselves as a utility. That's not possible, but I agree with Victor that we should be in the process and help it through. So I agree what Victor said. It's right.
All right.
So.
I think over to you, Shane, as a man who has used 3D capture a lot. And what do you think? You hear Victor saying that this should be a joint effort. Can you share some comments on that?
So actually, the way that how it works in Singapore is very typically regulations first, but the ground staff, the ground people like the contractors, the surveyors, and even asset owners need to, really tie in together to make a united push, because that's only the money has to come from somewhere. So the asset owners and the project owners have to be able to spec it in, and eventually all this thing will flow to the contractors and the surveyors. So I fully agree that this is a united push. But I think for this matter, I think SRA has taken the first step to try to digitize most of it, and I think for everyone is to keep an open mind. As the technology advance, there's really a lot of benefits that everybody can reap, even to the professionals and also for accountability. So this is something that everybody can look forward to together, especially as technology move forward. So it's not to say that we're replacing, but we are actually enhancing everybody's capabilities and also the accountability to a united underground register in the future. Yeah.
Great comment, Mr. Mack. I don't know if you have a comment, but I think also this transitions nicely over to my next question that I think you also could share your thoughts about, which is how surveyors and contractors can work together to ensure reliable data produced for every site. Do you like to give your comment on that?
Hello. Okay. Moving forward, our surveying industry has always been very in cooperation with all the authorities, moving into the IDD as well as into our smart city initiative. But as surveyor, most of our work is always supporting whatever that the government is always trying to mandate that is necessary. So you can realize just now why contractor and surveyor are fighting up and down who more responsible, because there's all this cost involvement. So because of that, I think surveyor will always be there for as long as there is technology competitiveness and working with all authority and contractor and a win-win situation. I think we can move forward in that direction. Thank you.
Great comment. And maybe on the other side here, Shane, who's represent the contractor, what do you think about what Mr. Mark just commented on, and about how contractors and surveyors can work together to ensure, yeah.
Yes. So I think it's kind of like a well-known fact that the labor market is very tight. So during the private discussion with Mr. Mark as well, we were mentioning that there's really a potential, let the contractor team to actually survey all this information. And then because that is already GNSS, it has a geolocation, and the endorsement and all this data can actually come from the RS themselves, so that is something that's more, we know is correct, and we are able to endorse on certain information. So that's where we can work together, and we are solving manpower shortages issue, but we are also making sure that the RS is endorsing on something that they can physically see, not say physically see, but they can trust the technology to be correct. And we can also see that, for example, in the web or in the browsers, that certain information, how many satellites has been there, is correct before any type of endorsement happens. So this is like a win-win situation. That's where we think that contractors and surveyors can work very closely together. It's not so much of replacing, but it's to enhance each other's capabilities. Yeah.
I'd just like to add on what Shane has said. What I'm trying to emphasize is that RS is not going to endorse all this information blindly, but because this technology involved here, there's always a lot of methods that surveyors can enhance into what they are doing to be checked by the surveyor, maybe not during the survey stage, because we know that this time constraint, there's not costly for a surveyor to put one surveyor in one project and for contractor to be bearing the cost. So there are a lot of issues that can be checked. For example, the AR, augmented reality. If that data has been scanned, surveyor can always use that and go back to the site to go and verify and tie to some other control before you can endorse the issue. So this is what I'm trying to emphasize, not just go there and sign and endorse blindly. Thank you.
I appreciate your comment and your openness. I think it's that you see a lot of opportunity in this, and enhancing really the job of the surveyor. I would like actually to move to you, Michaela, with this question. The question was about how surveyors and contractors can work together. Because you, as a third stakeholder, the asset owner, could you share some comments on like how you had worked together with surveyors and contractors in implementing the workflows of 3D capture of your subsurface utilities? Oh, you are muted again.
Sorry. Yes, I will try in English again. Okay. As I told you, for water supply, we have no. The water supply is doing the survey themselves, so we have no cooperation between them in this. For wastewater, is a bit different because we don't use our own contractor to do the work, so we have different contractors every time we make a trench. So this is very difficult because they don't know our standards. Every time we have to tell them our standards, and that is very difficult. And we haven't found a good way to do that, but I'm still working on it. So there must be a way, and when SmartSurvey or point cloud is more what's called normal in the branch, more used, then it's much easier because they know what we want. But right now, we don't have so many who is using their point clouds, and so we have to tell them how we want to have it every time, and that's difficult. But we have the workflow in the water supply, and it works. We have 6,000 point clouds in the Novafos, and a really, really good workflow.
I think it's an interesting perspective that, from a utility company both dealing with water and wastewater, that yeah, as I said, that water, it's because it has a certain form of contract, a long contract with some parties, it has inspired to easier adopt a new technology, whereas a certain, if you have other forms of contracts, it can be a more difficult challenge to implement new things. So that is definitely also an aspect, how we contract things, and yeah. Okay, anyone else on this comment on collaboration between contractors and surveyors, maybe from the audience? Are there anyone who would want to say something? We have one over here. This.
Yes, it's Otto from Redact. We've experienced in the recent years that making the technology simple to use invites less skilled people, let's call it nicely, to start using it. I think it's very important that somehow or other we have to find a way of maintaining the registered surveyor label to every technology, because if I can push a button on my iPhone and start doing this, who am I? Yeah, who are these people actually capturing this data? It's the same for the GPS systems. When we had theodolites, you had to have some skills to use it. Now you have a machine, you push a button, it says beep, and the thing is done. But they don't think about it anymore. And we see that particularly with the younger generations of surveyors, even if they've gone to the school, if the computer says it's so, it's so. And that's, I think, something that needs to be incorporated in the entire process, that despite the fact that it's easy to use, skill level needs to be maintained somehow. And I don't know where it falls in the chain of the individuals represented here, but maybe somebody could say, that's my task.
I think it's a great comment. It reminds me, as an engineer, we say that something in the lines of, engineering program can be very dangerous if you don't know the underlying mathematics and workings behind it. So yeah, great point. Any last follow-up on this question? What about you, Victor? Or maybe you would want to. I have the last question. Do we have time for a last question? How much have we been talking?
I think we are on time.
Let's take the last. So
yeah, okay.
What is the key to successful adoption of reality capture technology? The key, if we could just take a brief round, if you just had to say one key, maybe you, Shane, if you would start, like, what is just the number one key to successful adoption? What would
I
you
think
say that would be?
it's the ease of use to adopt this technology. That would be key to me. Yeah.
Great. Other one who wants to chip in on this question? Maybe you.
I think the key will be probably the collaborations of every partner, the government, the private, the agency. The collaboration, not just to mandate that you have to do it, but also to how to go training, pass down knowledge, and how to proceed with new bloods coming in. For example, I want to let Mr. Chia know one way we can try to have new bloods coming in, or maybe even change of profession for those older group, that SRA can help to push skill future to a certain courses that can gear towards this issue as we go along. Thank you.
Great. What about you, Victor? Do you have anything to comment on this? If you would like boil it down to a simple key to successful adoption,
Right. So we have heard that the two gentlemen spoke about the two key success factor. I think one is simplicity of the usage or of the adoption. The other one is about the capacity building. I think from my perspective is that I believe that the society or the community as a whole need to understand the value of 3D, the value of the additional information, the value of the details that we can capture in the reality capture. So these values are, when we talk about analytics, when we talk about smart city going into the future, and also the value that we can help in terms of the unreliable data that we have today. Right? So I think the understanding of that is important, and all effort should be put together to go towards this direction. Thank you.
Thank you. Yeah, unless Michaela, will you want to have a last comment or?
I think my comment is go out and use it and share it with the organization. Then you get the value, I think.
Thanks. And thank you. Thanks to you for joining. And also you, Victor, for being here online. I will forward, and thank you to you, Mr. Mark, and thank you to you, Shane. And Bharat, will you make the closing words?
Yep. Thank you. Wow, what an insightful panel discussion it was. Thank you. With this, we come to the end of this event. To summarize, yep. So to summarize, we have